Hi everyone. In today's video we'll be looking at how to reduce fractions. Now sometimes we have a pretty straightforward problem. Let's say for example 5/10, and some of you could look at this and right off the bat you could see that 5 is half of 10, and so naturally 5/10 is simply 1/2. But what about when the problem is not so straightforward? How can we approach this? Let's say for example we had 12 over 20 and we wanted to reduce this to its lowest form. Reducing a fraction means we want to get it to a form where we can no longer divide the top number or the bottom number by a same number without having a remainder, excluding 1, of course. That sounds like a lot, but let's take a look at what we're talking about. Is there any way we can simplify this and write it as smaller numbers? Well, if we look at the number 12, while there are many factors of 12, and by factors we're talking about numbers that we can multiply in order to get 12. First of all, let's start with that. Let's look at the factors of 12. We know that 1 times 12 gives us 12. We also know that 2 times 6 gives us 12. 3 times no whole number, yes, 3 times 4 would also gives us 12, sorry, and 4 times 3, but we'll skip that one. And I think for now, that will do. Then we can come back and we can look at the factors of 20. We also know that 1 times 20 gives us 20. We know that 2 times 10 gives us 20. 3 times no whole number will give us a 20. So we move on to 4, and we know that 4 times 5 gives us 20. Yes, we see that these two have the number 2 in common. And so we know that there is a 2 inside of 12 and a 2 inside of 20. And we could go ahead and divide 12 by 2, and we would get 6. And we could also divide 20 by 2, and we would get 10. But the question is this in its lowest terms? Well, we could also divide 6 by 2 again, and we would get, let me try and make some room so that we could see this. If we were to divide 6 by 2, then we would get 3. And we could also divide 10 by 2, and we would get 5. Question is this in its lowest terms? Well, can we divide 3 by 2 to get a whole number? Nope. Can we divide it by 3? Yes. But could we also divide 5 by 3 and get a whole number? Nope. That means there is no whole number we can think of that will divide into 3 and divide into 5 at the same time and not leave a remainder. And so we know that 3 over 5 is in our lowest terms. Look at what we did, however. We divided by 2, and then we realized we could have divided by 2 again. So maybe if we had divided by 4 to begin with, we would have gotten to our answer a little bit sooner. And that is the point that I wanted to make when we were looking at the factors of 12. I'll put them back up. 1 times 12, 2 times 6, 3 times 4, and also the factors of 20. We had 1 times 20, 2 times 10. We didn't have a 3, then we had 4 times 5. You always want to choose the largest possible factors that you can find. Why? Well, if you choose 1, that's the smallest, there's always a chance that there are other factors. We chose the 2, and we realized that after we brought it down to 6 over 10, then we could also divide both 6 and 10 by 2 again. But by choosing the 4s, let's see what happens. If we divide 12 by 4, we get 3. And if we divide 20 by 4, we get 5. And we know that there is no other number that would divide into both 3 and 5, because from our factors we saw that 4 was the largest common factor between these two numbers. And so your best bet when trying to reduce fractions are to find the largest common factors. Now let's try another fraction to see if we can apply what we just learned. How about I don't know, let's try 8 over, let's say, 48. What are the factors of 8? I always like to start with 1, and then we work our way counting up to 10 to see all the factors. So what I mean is I say 1 times what gives me 8. 1 times 8 gives me 8. Then 2 times what gives me 8. See, I'm counting 1, 2, 3 going up in order. 2 times 4 gives me 8. 3 times what gives me 8? 3 times no whole number will give me 8. So I skip 3, I move on to 4. 4 times 2, which is the same as the previous line. So we'll just erase that one. And then we say 5 times what gives me 8. 6 times what? 7 times what? And we realize that these are all the factors of 8 that we have. Then we move on to 48. 1 times what gives us 48? Where 1 times 48 is 48. Then 2 times 24 will give us 48. Then we want to know 3 times what will give us 48. 3 times 16 will give us 48. Then we want to know 4 times what will give us 48. 4 times 12 will give us 48. Then we want to know 5 times what? We skip 5 because 5 times nothing will give us 48. We move on to 6. We know that 6 times 8 will give us 48. Then we say 7 times what? 8 times what? We know that if 6 times 8 gives us 48, then 8 times 6 will also gives us 48, but we can skip over that. In fact, I would not go any further because from finding the factors of 8, I realized that I only had 4 factors, 1, 8, 2, and 4, the largest of which is the 8. And now that simply means with no other factor being larger than 8, it doesn't make sense. I try to find another factor here that's larger than 8. So 8 is the largest factor that I will be able to use from this one, because both of them has to go into the same number has to go into both numbers, and we can see that 8 is the largest number that will go into both numbers because there's no factor larger than 8 in the number 8. And so we will work with 8. So we come back to this problem and we say 8 divided by 8 gives us 1, and 48 divided by 8 will give us 6. And we see that this fraction reduced to its lowest form will be 1 over 6. Another approach that some people use is simply to cross out factors. Let's try that approach. Crossing out factors, it works. However, it's not my go-to means of reducing fractions, and I'll show you why. Let's say we wanted to find the factors of 12. As we established before, there are many factors of 12, and unless you know how to factorize 12 most efficiently, then you're not going to stumble across the answer immediately. You could factor it in terms of 2 times 2 times 2, and that there is 6 times 2 times another 2. So 2 times 2 is 4, 4 times 2 is 8, and that will not work. So let's just do it like this. If we were to factor it as 2 times 6, what would we factor the 20 as for it to work? Well, we could factor the 20 as 2 times 10. And we see that we have a 2. That's common to both. And so we could cancel out the 2's and we're left with 6 over 10. Still, 6 over 10 is not the lowest form. We would then have to factor the 6. And if we did 6 times 1 and 10 times 1, that would not help us because the 1's would cancel and we're still left with 6 over 10. Which is why I don't like this method, because you're still guessing as to what is the appropriate factorization to use. Then you try 3 times 2, and then you try 5 times 2, and then you realize that the 2's cancel, and so you're left with 3 over 5. But going back to what I was saying earlier is, what if you did not automatically think of 2 times 6? And you tried some other factorization, then you'd have to keep using trial and error until you come to the correct factors that you need to use, as opposed to the previous method that I used, where I just list all the factors to begin with and then I choose the largest factor that's common to both numbers. Hopefully you find this video helpful, and don't forget to like, share and subscribe at the bottom of the video.